Good day, this is Russell from the Tate Geological Museum, and today I'm going to be talking to you a bit about igneous rocks. Now, igneous rocks are rocks that start out melted, and we've got a name for that melted rock. If it's oozing out at the surface of the earth, like say coming out of a volcano, what do we call that rock? Melted rock coming out of a volcano? Do you know? That's right, lava. But melted rock can also be found deep under the ground, and that subterranean melted rock has a different name. Can anybody tell me what that kind of rock is called? Yep, magma. Melted rock deep under the ground is called magma. And those two different kinds of rock will solidify and crystallize and produce different types of solid rock when they're done. Let me give you some hard examples. If lava cools and hardens at the surface so quickly that it can't actually form any crystals, then you get this stuff right here. This is obsidian, also known as volcanic glass. So if that lava, say, flows into a stream or a river or lake or something, it'll just freeze into this glass and not form any crystals at all. So that's one thing that you can get from cooling lava. However, lava can also produce this stuff. Now, this would have started out, once again, as lava at the surface, but this time with a whole lot of water in it. And as that melted rock reaches the surface, the water expands into water vapor and blows up the liquid rock full of little tiny holes called vesicles. And in this type, there's so many vesicles that it'll actually float. So if you see a floating rock, you know you're looking at pumice, because that is not natural behavior for a rock. And that is because of the water inside of the lava. Now, if you get lava cooling a little bit more slowly, it will form crystals, but they're going to be very small, and you'll end up with this stuff. So this is called rhyolite. And you cannot see these crystals without a magnifying glass. It's an aphanitic, and that's just a fancy word that means having very small crystals, an aphanitic igneous rock. Rhyolite is pale and lightweight, not as lightweight as pumice because it's solid instead of being full of vesicles, but it's made out of pale, lightweight minerals like feldspar, quartz, and mica, and that makes it not very heavy, and generally makes it pale. But incidentally, there is a whole lot of rhyolite that can be found in the Yellowstone area. So that shows us that there was a lot of volcanic activity up in that area about 50 to 60 million years ago, and great flows of lava covering large areas of the surface back then. Now, if you've got lava cooling at the surface, but this time with lots of dark, heavy minerals like plagioclase and pyroxene and olivine, then you'll end up with a different sort of rock, a heavier, darker rock. This is basalt. And most of the rocks that are underneath the mud at the bottom of the sea are this stuff, basalt. Fortunately for us, you can also find it on the continents as well. There's quite a bit of basalt in Idaho and eastern Washington. So that'll go over here on this side of the chart. Aphanitic, small crystals on this stuff, and dark, because it's made out of those dark, heavy minerals. Now, you can also get rock that's in between. Here we've got a rock that is aphanitic, small crystals, but this time formed from a mix of both the light and the dark minerals, and that gives us andesite, named after the Andes Mountains, where they were first recognized as a distinct rock type. Okay, so that's what you get from lava. Now, what about magma? Well, the most abundant rock that you can find that forms from the crystallization of magma is this stuff. There's literally millions, even billions of tons of this right in the core of Casper Mountain, so finding some of your own is not difficult at all. This is granite. And here, once again, we've got quartz and feldspar and mica, lightweight, pale minerals making it up. But look at those crystals. You can see them from the comfort and privacy of your own home right now. They're like an oatmeal cookie, just chock full of great big chunky crystals that you can easily see with your unaided eye. So this is a Phaneritic Rock, which means evident crystals. So you can see that in this granite. Now, if you've got the darker minerals making up your granite, olivine is one of the most abundant of those minerals. This is almost pure olivine in this specimen right here. Here you've got a mix, including the olivine and also the pyroxene and the plagioclase, a bit of amphibole. This is diabase, which can be found in veins, dikes on top of Casper Mountain. Well, you can't feel this. Come to the museum in the summertime and you can pick this up in your own little hand, and you'll notice that it's a pretty heavy rock for its size because of those dark heavy minerals. So gabbro, which is very, very rare, and diabase, good examples of a phaneritic but mafic igneous rock. Finally, just as with the andesite, you can get coarse-grained rock with a mix of both the lighter and darker minerals, and that is diorite. I don't have any diorite myself, but here I've got some dacite that can stand in for it right there. So just with those three criteria, you can classify your igneous rocks into one of these categories.